Good morning, Algebra 2. Let's get going. Unit 4, Day 2. Factor by grouping. If you ever see 1, 2, 3, 4 terms, that is almost always an indicator that you're going to need to factor by grouping. Let me create two groups. There's group 1. There's group 2. Now, out of group 1, we could factor out an x. Then open up a set of parentheses. If we divided group 1 by x, that would leave us with x plus 2. Now over here in group 2, we could factor out positive y in parentheses. And if we divided group 2 by y, that would leave us with x plus 2. Now, almost always in this class, almost always, these two parentheses should match. There are occasions when they won't, but they usually do. Now, here's your final answer. Your final answer consists of two parentheses. One of the parentheses are our outside terms, and the other parenthesis is the matching set of parentheses. Okay, now let's take a look at example B. Let's create our two groups. Group 1, group 2. Looking at group 1, looks like the greatest common factor is going to be 4a. And if you divided group 1 by 4a, that would leave you with 2b plus 3. Group 2, we could factor out -5. And if you divided group 2 by -5, that would leave you with 2b plus 3 again. And there is our final answer. One parenthesis is the matching terms, or matching, I'm sorry, the outside terms. The other parenthesis is the set of matching. We will use a combination of factor sum table and factoring by grouping given ax squared plus bx plus c. Now this is the formula in standard form. Whenever we're factoring, it's going to look something similar to this. And you want to make sure that it is in this particular order. You want your term that is being squared first, then your x, then your constant. It makes it a little bit easier to identify what our a, b, and c values are. Now, it's pretty simple to identify. Our a value here is the number in front of x squared. The b value is the number in front of x. And then the c value is just the number without the x. Now, we're going to factor. And I don't really care about this table so much. I'm just going to use the t-chart. Here's how you factor trinomial where a is greater than 1. See, a is 3. You're supposed to multiply a times c. Number in front times number in back. Well, 3 times 6 is 18. These are all of the factors of 18. Now, that number on top of my t-chart, when it is positive, it tells me a couple of things. If it's positive, that means our factors have got to add to get the middle term. Well, 1 plus 18 is 19. 2 plus 9 is 11. Hey, we found our winner. 3 plus 6 is 9. Nope, not those. If that number on top of your t-chart is positive, it also tells you that these signs are going to be exactly the same, either plus plus or minus minus. And since it's -11, they must be minus minus. And you could just double check yourself if you wanted to. -2 plus -9 is -11, and -2 times -9 is positive 18. Now you're going to want to create a grouping problem. You remember what we did at the top of our notes? Factor by grouping. We're going to do the same thing, except now we have to create our own grouping problem. Now that I have my grouping problem, let me tell you how I got it, in case you don't know. Well, look at our original trinomial. Notice the number in front is still exactly the same. Notice the number in back is still the same. What about that negative 11x though? Well, those are our factors. Negative 2 given an x, negative 9 given an x, and if you were to combine them, you get negative 11x. So that's where our grouping problem comes from. Let's create our two groups. Group 1, Group 2. In Group 1, we could factor out an x, open parenthesis, and if you divide Group 1 by x, it leaves you with 3x minus 2. Group 2, you could factor out negative 3. And if you divide Group 2 by negative 3, that leaves you with 3x minus 2. Let's keep our outside terms and matching parentheses. That is your answer. Example C. Number in front times number in back. Since that number is positive, it means our factors are going to have the exact same signs, either minus, minus, or plus, plus. It also means they have to add together to get the middle number. So we must be using 4 and 5. Now, since that number in the middle is negative, then those both must be negative. Negative 4 plus negative 5 is negative 9. Negative 4 times negative 5 is positive 20. Now let's create our group. Group 1, Group 2. In Group 1, you can factor out a 2x. And if you divide Group 1 by 2x, that leaves you with x minus 2. Group 2, let's factor out a negative 5. And if you divide Group 2 by negative 5, that leaves you with x minus 2. There's your answer. Example D, number in front times number in back, or A times C. 6 times negative 10 is negative 60. A lot of factors for this one. Now, this is a scenario where knowing your factoring rules is a necessity. Because you might be thinking, well, we need the factors of negative 60 that can combine to get negative 17. So not that one, not that one, not that one, not that one. There's two sets of factors here that can in some way get us negative 17. If that number on top of your t-chart is negative, that means your signs are going to be positive and negative or negative positive. It also means your factors have to subtract to get the number in the middle. Therefore, that eliminates 5 and 12. 20 minus 3 is 17. Well, since we need it to be negative 17, then here's what we really need to do. 3 minus 20. 3 minus 20 is negative 17, and 3 times negative 20 is negative 60. Now let's create our grouping problem. Group 1 and group 2. In group 1, you can factor out a 3x. If you divide group 1 by 3x, that leaves you with 2x plus 1. Group 2, you can factor out a negative 10. If you divide group 2 by negative 10, it leaves you with 2x plus 1. And there is your final answer. A word problem. Oh my gosh, what do we do? Well, what have we been doing this entire lesson? Factoring. That's probably what you're going to need to do to solve this word problem. So listen, on your next test, if you're given a word problem and you don't know what to do, well, try factoring. Maybe that's what you need to do. Part E, the area of a rectangle is represented by the expression 7x squared minus 33x minus 10. In terms of x, what is the length of the sides of the rectangle? Let's factor. Number in front times number in back. A times C. Now, the factors of negative 70, there's quite a bit of them. I mean, not that many, but I'm just going to give you the ones that we need here. We need 2 and we need 35. Since that's negative, that means these are going to be different signs. It also means they have to subtract to get the number in the middle. And positive 2 minus 35 gets us negative 33. Let's group. Now I'm going to do something a little bit different that I haven't done up to this point. I'm just going to flip these two. When you're substituting your factors here, it doesn't matter which order you put them in. Group 1, group 2. In group 1, we can factor out 7x, leaving us with x minus 5. In group 2, we can factor out positive 2, leaving us with x minus 5. And now we have solved in terms of x, what is the length of the sides of the rectangle? One of our sides is 7x plus 2. The other one is x minus 5. Now, if you want, practice 1 through 4 on your own. Then go check the answer key on my Canvas page and see how you did. If you're not getting this stuff right, come talk to me. Room 402. Let me say that one more time because it wasn't very clear. Room 402, and we'll go over it together. Move on to the next side of our notes. Example F, root 14 times root 10. When you're multiplying a root with another root, as long as the roots are the same, and here's what I mean by that. These are both square roots. Since they're both square roots, you can multiply both of these square roots. So square root 14 times square root 10 is square root of 140. If you simply put 140 on your next test, that's not right because this can be reduced. You have to reduce when necessary. Just divide it by 2. 140 divided by 2 is 70. Divide that by 2. 70 divided by 2 is 35. Well, that's not divisible by 2 or by 3, but it is by 5. And 35 divided by 5 is 7. Now here's a set of twos, a pair of twos. I should state a little bit more accurately. We're looking for pairs here. There's a pair of twos, and the 5 and 7 are left over. Anything that I have underlined goes back inside, and what I have circled goes on the outside. And then you just need to simplify here. 5 times 7 is 35. Example G. When we multiply these terms here, I want you to kind of think of it like multiplying like terms. Notice the 2 is in front of the square root, and here the number 3 is in front of the square root. So let's just multiply the numbers in front of the square roots first. 2 times 3 is 6. Square root. Now let's multiply the numbers inside the square roots with one another. 6 times 8 is 48. If you put 6 root 48 on your next test, that's wrong, because this can be reduced. Let's reduce it. 2 and 24. 2 and 12. 2 and 6. 2 and 3. Let's look for pairs. There's a pair. There's a pair. That's left over. Now, before I just come up with my final answer, let's not forget we originally had a 6 on the outside. That doesn't just go away. Anything I have underlined goes back inside the root. Anything that I have circled goes on the outside. And since we had 2 circles, that means one number from each circle gets moved to the outside. And now we multiply all those together. Your final answer, 24 root 3. Example H. This one isn't really too bad. Now we're adding or subtracting roots, and in order to do that, the number inside the square root has to be exactly the same. So I'm going to circle square root 3 and -5 root 3, because both of those have the exact same number inside the square root. Now we can add them or subtract them or whatever the signs happen to tell us. Well, this is positive root 3 minus 5 root 3. That gives you -4 root 3. Now I'm going to circle positive 4 root 2, positive root 2. We can add those because the number inside the root is exactly the same. And 4 root 2 plus root 2 is 5 root 2. And you leave your answer just like that. You cannot combine those terms. Example I. Currently, we don't have any numbers inside the square roots that are identical, but these can be reduced. This one can't reduce any further, but this one can be reduced. There's a pair that's left over. Now, if I bring down my simplified answer, if you will, let me bring down the fact that this root inside the root is going to go a 2 and a 3. Outside the root goes a 2, but let's not forget there was also a -3 in front of it. So -3 root 24 reduces to -6 root 6. And then let me bring this down. All right, now let me simplify this one here and let's see what we get. This one would simplify to 3 goes back inside, 2 goes on the outside, and this root was positive. Okay, now we've simplified. We can simplify further. Now we can combine these two square roots. 2 root 6 minus 6 root 6 is negative 4 root 6 plus 2 root 3. Final answer. Example J. If I multiply 5 times negative 2 root 5, did I say that right? If I multiply square root 5 times negative 2 root 5, this would be the result. Now, if I multiply square root 5 times positive 5, this is the result. You then want to check to see, can we simplify a little bit more? And we can. The square root of 25 is 5. 5 root 5 will not reduce anymore. Now we can simplify a little bit more. Negative 2 times 5 is negative 10. And now you're finished. Guided practice. Practice those on your own if you'd like. Check my answer key in Canvas to see how you're doing. And if you're not getting it right, come pay me a visit. We'll work on it together. Have a good day.